Alright, so for the second part of this paper and the last part, we have questions 4 and 5. So ammonia is an important chemical. Ammonia is a base. So what is a base? A base is a proton acceptor. Straight up, it accepts the hydrogen ions that are being transferred from the acid. And now we have to write a word equation to show that ammonia behaves as an acid. So basically any word equation that has ammonia reacting with any acid and giving it salt. So for example, hydrochloric acid gives you ammonium chloride. Now, ammonia reacts with chlorine, and this is the equation. Calculate the volume of chlorine measured at room temperature and pressure needed to react with 0.68 grams of ammonia. So we're given the 0.68 grams of ammonia, and that chlorine is at room temperature. So now 1 mole of ammonia is 17 grams, and X is 0.68 grams. We're going to cross multiply and find what X is. X is 0.04 moles. Now from that, we know that NH3 to Cl2 is a 2:3 ratio because you can just use the coefficients in the equation that we're given. Now, 0.04 moles of NH3 and X, we don't know what Cl2 is. So we're going to cross multiply again. So 3 times 0.04 divided by 2 will give us 0.06 moles. Now, 1 mole of chlorine is 24 decimeter cubed. Basically, any gas at room temperature and pressure takes up or occupies a space or a volume of 24 decimeters cubed. But if you've noticed in the question, they're asking for centimeters cubed this time and not decimeters cubed. So you're going to multiply it by 1,000. So 1 mole of chlorine gives you 24,000 centimeters cubed. 0.06 moles gives you how much? We don't know. We're going to cross multiply again, and X will equal to 1440 centimeters cubed. Now, for part II, the chemical equation can be represented as shown. Use the bond energy in the table to determine the energy change. So we need the energy change to break bonds. So the bonds being broken, that's happening in the reactants, right? So NH is 390, and there's 3 of it. And then 2 of those, so 3 times 2. So 390 times 3 times 2 gives you that many kilojoules. Then for the chlorine, there's 3 of it, so 240 times 3. Then the total, you're going to add them up together. The next, we're supposed to find the energy needed to break, the energy released when bonds are formed. That happens in the products because bonds are forming, right? So N and N, that's 945. The HCl is 430 times 6 because they said there's 6 of it. You just check the coefficient. Then you add it up together, it gives you 3,525 kilojoules. Now we need to find the energy change for the reaction between ammonia and chlorine. So what you're going to do is multiply the bonds broken of the bonds formed from the bonds broken. So 360 minus 3,525, which gives you negative 465 kilojoules. That negative indicates that it's an exothermic reaction, as in more energy is released than used. So the energy that's released when forming the bonds is much greater than the energy that was used in order to break the bonds in the reactants. And that is why the reaction is exothermic. Now, ammonia reacts with oxygen at a high temperature in the presence of a suitable catalyst to form nitric oxide. Now, explain how this chemical equation shows ammonia acting as a reducing agent. It acts as a reducing agent because it's getting oxidized. Basically, it's gaining an oxygen, or in other words, it's losing a hydrogen. Another form of finding out something is oxidized is through a little mnemonic. What is it called? I don't know. But it's oil rig. So oxidation is loss of electrons, reduction is gain of electrons. Now, the catalyst would most likely be platinum, and that is because it's a transition metal, and transition metals are usually catalysts. Now, alcohols are a family of organic molecules which have the same general formula. What is the name given to any family of organic molecules which have the same general formula and similar chemical properties? That's the homologous series. Now, the general formula of alcohols is CnH2n plus 1 and then OH, or you can put all the H's together. So it's going to be CnH2n plus 2 and then O. To help you figure out what the general equation is, you can draw out alcohols in the displayed formula. But other than that, you should have it pretty much memorized. Now, propanol can be made from propene. Name the reagent and give the conditions needed to convert propene into propanol. The reagent is steam, and the condition is the use of a catalyst. Now, the double bond here, I drew it out for the propanol. The double bond ends up breaking, and the steam or the hydrogen and the OH end up taking up its place, and so you have propan-1-ol. And the catalyst is nickel, but so far I don't think you guys should be aware of that, but it's still good to know in case they ask what that catalyst is. Now we're supposed to write a chemical equation for the combustion of propanol. So propan-1-ol, so that's going to be the propanol plus the oxygen will always give you carbon dioxide and water, and all you have to do is simply balance out the equation. Now for part D, a simple sugar can be represented like this. Complete the diagram to show the part of the carbohydrate polymer made from this simple sugar. So now we have the OH and the H. They come together and they release a water molecule. This is condensation, right? And so you're only left with that oxygen. So between each block, you're going to just have an O. And that's it. Name the chemical process which occurs when a carbohydrate polymer is broken down into simple sugar. So basically the opposite, where you're adding the water back in, and that is hydrolysis. And hydro has something to do with water. That's how you know it includes water itself. Now, what is needed for this process to occur is an enzyme, or you can say heat and an acid, and the acid is usually a dehydrating agent, something that will get rid of the water, like concentrated sulfuric acid. Now, in chromatography, what is the name given to the type of substance used to identify the position of the simple sugars on the chromatogram? That would be the locating agent, and you should know this for sure. And you use this locating agent especially when you cannot, that's when the little substances are invisible or basically colorless. So the student calculated the RF value, and we need to complete the expression. That is the distance traveled by the substance over the distance traveled by the solvent. This is just something that you need to memorize. Now, how could a student identify the simple sugar from this value? They just need to compare it to a known data, and that is it. So we already have known data or known RF values, and the one that you get, you just compare it to that, and then you can find out the substance or the sugar. Now, this doesn't always work out, and that is because some substances have similar RF values, and so you can't really tell them apart. But anyways, you guys, we are done with this paper, and I hope you guys find it helpful, and I'll see you on the other side. Bye!